Okay, so let's do this first problem. So when we're, okay, now that I'm on the right screen. Okay, so we have this integral that we want to integrate. The first thing that we should do is draw what this region is. So D is the region y is greater than or equal to 0 between the circles at with center 0, 0 of radius 1 and 3. Okay, so what is this going to be? So let me just, off to the side here, let me draw what this region is going to look like roughly. Okay, so it's the circle is where y is greater than or equal to 0, so we only care about the top half of the plane here. And it's between the circles with radius 1 and radius 3. So this would be a circle of radius 1, and this would be the circle of radius 3. Okay, this is in x and y coordinates. So the region that we care about is this region here. Okay, again, this is a circle of radius 1, this is a circle of radius 3. So in polar coordinates, the theta interval is going to go from 0 to pi, because the angles go from 0 to pi, and the r interval is going to go from 1 to 3, because for every fixed value of theta, we just integrate r values from 1 to 3, just like this. For every fixed value of theta, we integrate the r values from 1 to 3. Okay, so we're going to switch to polar coordinates. So then the first thing that we do is we write out the integral. So r is going to go from 1 to 3. Theta will go from 0 to pi. Okay, now don't forget to write the r dr d theta. Don't forget, whenever you switch to polar integrals, you have to write this r dr d theta. Now the function that we're integrating, so it's going to be sine of 4 pi times x squared plus y squared. X squared plus y squared is r squared, so this becomes sine of 4 pi r squared. Okay, now this is the integral that we want to do. Okay, we completely forget about this integral and we concentrate on this one. So this is a good u substitution integral. So we're going to say u is equal to 4 pi r squared. So this means that du is equal to 8 pi r dr. And so what does this integral become? Well, the theta integral, that stays the same. This is going to be the integral from theta equals 0 to pi. Okay, so we'll deal with the limits here in a second. This is sine of u. Okay, so if this is our expression relating du and dr, this says that dr is equal to du over 8 pi r. So this is going to be du over 8 pi. The r there cancels with the r there. That's why we chose this change of variables. And now u is equal to 4 pi r squared. So the bottom limit and the u is going to be 4 pi. Okay, and the top limit is going to be 4 times pi times 3 squared. So this is going to be 36 pi. Okay, and so overall, we'll pull out this 1 over 8 pi. Okay, now what's going to happen? Well, look, the antiderivative of sine u is minus cosine u. So this is going to be cosine of 4 pi minus 36 of 4 pi. So this is going to be the integral theta equals 0 to pi. Okay, now this inner integral, this u integral, is going to be cosine of 4 pi cosine of 4 pi minus cosine of 36 pi d theta. Well, cosine of 4 pi is 1. Cosine of 36 pi is equal to 1. So this is equal to 0. And that's it. Okay, so now let's do this problem. So R is going to be the region that lies to the left of the y-axis between the circle of radius 1 and the circle of radius 4. Okay, so the region is kind of similar to what we had before, but going to be on the left-hand side. Okay, so the region that we have will look something like this. So this is a circle of radius 4. This is a circle of radius 1. Let me go ahead and draw the x-axis. So it's like this left half of a washer. It's this part right here. Okay, now in polar coordinates, theta is going to go from pi over 2 to 3 pi over 2. Okay, and r is going to go from 1 to 4. Okay, so switching the polar coordinates, this integral is the following. So r will go from 1 to 4. Theta goes from pi over 2 to 3 pi over 2. Okay, don't forget to write the r dr d theta. Okay, so now x is r cosine theta, y is r sine theta. So this is 5r times cosine theta plus sine theta. Okay, that looks a little bit better. So if we do the r integral first, I'm going to pull out this 5. This is 5 times the integral from theta equals pi over 2 to, this is pi over 2 to 3 pi over 2. So this r integral, well, we're really integrating r squared. So that's going to be r cubed over 3. The antiderivative of r squared is r cubed over 3. So I'll divide by the 3 here. Okay, so it's going to be 4 cubed minus 1 cubed. So 4 cubed is 4 times 4, which is 16 times 4. 16 times 4 is 64. So this is going to be cosine theta minus sine theta times 4 cubed is 64. 64 minus 1 cubed, that's 63. 63 d theta. Okay, now to do the theta integral, so notice that the antiderivative of sine theta is minus cosine theta, and when you evaluate cosine theta at 3 pi over 2 and pi over 2, both of those are 0. So the only part of the integral that's non-zero is cosine theta. The antiderivative of cosine theta is sine theta, so it's going to be sine of 3 pi over 2 minus sine of pi over 2. Sine of 3 pi over 2 is minus 1, sine of pi over 2 is 1, so this is going to be minus 2. So overall, this is going to be minus 2 times 5/3 times 63. So let me just write this all out. Minus 2, that is a 2, times 5/3 times 63.